Hello, this video is on least common multiple. Make sure you have your notes packet or a piece of paper for you to be taking notes on during this video. A couple of vocabulary words that we need to make sure we understand. Multiple is a very important one, is the product of any number and any integer. So if we think of the multiples of 10, basically we're just counting by 10. So 10, 20, 30, 40, 50. If we think of the multiples of 3, it would be 3, 6, 9, 12, 15, 18, and so forth. Least common multiple of two or more numbers is the smallest of their common multiples. So if you think of greatest common factor, we were thinking of the greatest factor that they have in common. Multiples now are counting up, and we are trying to find the least or the smallest of their common multiples. So if we find the least common multiple of 10 and 15, if we look at 10, and we've listed out all the multiples of 10, and then we list out all the multiples of 15, we can see that they both have a 30 in common, so the least common multiple would be 30. So factors versus multiples, very important for you to make sure you understand. So the factors of 12 would be 1 and 12, 2 and 6, and then 3 and 4. So remember, it's two numbers. So like 1 times 12 is 12, 2 times 6 is 12, and then 3 times 4 is 12. So two numbers multiplied together to get that number. Multiples of 12 then would be starting at 12 and then counting up. So 12, 24, 36, 48, 60, and so forth. Pause me and do 20 and 11, factors and multiples. Write them all out. Factors of 20 would be 1 and 20, 2 and 10, and then 4 and 5. Multiples would be 20, 40, 60, 80, 100, and so forth. Factors of 11 would be 1 and 11, because that's all that the numbers multiplied together to get to 11. But then the multiples would be 11, 22, 33, 44, 55, and so forth. So there's always multiples that go on and on and on of that number. The factors, remember, there could just be 2 or there could be more. There's a few different ways to find the least common multiple of two numbers. LCM is the abbreviation for least common multiple. So one of them is listing out the multiples of the two numbers. So if we want to find the LCM of 12 and 9, we're going to list out, and we're just going to go on and on with 12 and 9. So 12, 24, 36, 48, 60, 72. And I'm just going to stop there and do a few of the 9 and see if I need to add more on the 12. You should be doing this in your notes packet or on your page with me as I'm doing it here in the video. So 9, 18, 27, 36, and then I notice that they both have a 36. So that means I can stop because they are going to have another multiple in common. They'll for sure have 72 in common and more after that. But 36 is the smallest one because there's nothing smaller than 36 that they both have in common. So the least common multiple of 12 and 9 would be 36. And I know that because 12 times 3 equals 36 and 9 times 4 equals 36. So then I know that it works. Another method that I want you to practice is using prime factorization to find the LCM of two numbers. So if we're going to find the LCM of 16 and 20, we can use prime factorization. So we can take 16 and we can take 20 and find the prime factorization of both of them. So 16, I know 4 times 4 equals 16. Neither of those are prime, so I'm going to keep going. 2 times 2, both of those are prime. 2 times 2. Both of those are prime. So my prime factorization of 16 is 2 to the 4th power. And then I go to 20. 4 times 5. 5 is prime. And then 2 and 2. So my prime factorization of 20 would be 2 squared times 5, because I have 2 2's and a 5. The 16, 2 to the 4th, is because I have 1, 2, 3, 4. So the way that we find the LCM is we take each prime number involved within both numbers and take the highest exponent. So I can see that they each have 2's. 2 to the 4th is higher, so I'm going to take that. And then there's a 5 down here, so I'm going to pull that out. There's only one 5, so I'm just going to take that 5. So then my LCM would be 2 to the 4th times 5. 2 to the 4th is 16 times 5 would be 80. And then I ask myself, yep, 16 times 5 equals 80. 20 times 4 equals 80. So that makes sense that the LCM of both of them would be 80. And if I think about it, if I were going to list out my factors and I did 20, 40, 60, 80, as I'm listing out my factors, I know 16 doesn't go into 20 equally. It doesn't go into 40 equally. It doesn't go into 60 equally. It does go into 80 equally. So that checks out. Another method is what we call the ladder method. We also call it the cake method because it kind of looks like an upside down cake. Is very similar to way back when we did the prime factorization using this method just with one number. So what we do is we have our two numbers. We're going to find LCM of 16 and 20 again. And we start taking out prime numbers that they can both be divided by. We actually can do any number that they can be divided by. So it doesn't matter if it's a prime or not. But if we start with primes, that narrows it down pretty quick. So I know 16 and 20 can both be divided by 2. So I'm going to put a 2 out here. And then 16 divided by 2 is 8. So I'm going to put that right below the 8. 20 divided by 2 is 10. So I'm going to put that right below the 20. And then I'm going to add another layer here because 8 and 10 can both be divided by 2 again. So basically I keep going until there is a number that they both can't be divided by. So 8 divided by 2 is 4, 10 divided by 2 is 5. So now I have 4 and 5. There isn't a number that 4 and 5 can be divided by. So I'm done. So then I circle all the numbers on the outside, and then we multiply the L. So we would do 2 times 2 times 4 times 5. 2 times 2 is 4, times 4 is 16, times 5, and we get 80, which is the same as what we got when we did the other two methods on the previous slides. Okay, lastly, I would like you to pause me and try to find the LCM of 12 and 16 using all three methods. Maybe one or two of the methods are confusing to you, so I at least want you to try one for sure, and then unpause me and check your work and fill in the rest of the work that you didn't do. So 12 and 16 using the multiples. 12, I'm going to list out 12, 24, 36, 48. I'm going to stop there for now. And then we have 16. So 16, 32, 48. I see that they both have a 48. So LCM would be 48. Prime factorization, 12 and 16. So I can do 3 and 4. And then 2 and 2. So 2 squared times 3. And then 16 is 4 and 4. We already know that the prime factorization of 16 is 2 to the 4th. 2 to the 4th is bigger than 2 squared, so I'm going to pull out 2 to the 4th, and then I'm also going to pull out this 3. So 2 to the 4th is 16 times 3 is 48. And then using the cake method, we would do 12 and 16. So 12 and 16, we can divide them both by 2. 12 divided by 2 is 6. 16 divided by 2 is 8. Do 2 again. 6 divided by 2 is 3. 8 divided by 2 is 4. 3 and 4 both cannot be divided by anything else. So I circle everything on the outside and I multiply 2 times 2 times 3 times 4. 2 times 2 is 4. Times 3 is 12. Times 4, we get 48. Make sure these notes get into your backpack so they are here with you in school tomorrow. Have a great day.